Okay, last session of the day. Thanks for coming along, guys. Hope you stay awake for the whole session. I'm trying to make it a little bit shorter because I know everyone wants to get out of here on time. There's a lot of stuff to cover off, so we'll get going. So today we're going to look at monitoring your on-premise and cloud services from a single pane of glass. Essentially, this means using SCOM and some of the management packs that are available for Windows Azure, Amazon Web Services, and the new Global Service Monitor from Microsoft. My name's Luke Notley. I'm a Senior Tech Consultant for Red Ember. We're a hosting provider based out of Perth. So today we're going to look at some of the requirements and goals that you might have from a monitoring perspective. Then we'll do a quick overview on SCOM 2012, SP1, and then I've managed to slide in some R2 features in there as well. Hands up who's using SCOM 2012 at the moment and who's on 2007 still? Okay, about half and half. Then we'll have a look at the application performance monitoring, which is built into SCOM 2012 now. So that was the AviCode acquisition that Microsoft made. Then we'll have a look at the Azure Management Pack. So this is the management pack that's currently in preview. So some stuff does not work. Apparently that's going to get released and revved when all the R2 stuff drops as well, along with System Center. So hopefully all the bugs will be fixed by then. Then we'll take a look at the Amazon Web Services Management Pack. So this was developed by a company called ViaCode. And ViaCode sounds similar to AviCode. So basically when Microsoft bought AviCode, they spun out part of the guys that didn't get bought into ViaCode. And ViaCode actually wrote this management pack for Amazon. And then we'll have a look at web application availability and the global monitoring using the Global Service Monitor from Microsoft. Who's heard of the Global Service Monitor? Yep, couple? Okay. So hopefully this is not what your usual day in your jobs at the moment looks like. But if it is, hopefully some of the stuff you're going to get out of today will help you de-stress and not look so stressed out. So let's have a look at some of the goals that we might have. So really, if you look at it from a holistic point of view, some of the goals that we would want to have is to be able to look at application availability and reliability and performance, and kind of end to end. So we want to look at what it looks like from a customer point of view, then the application itself, and then all the way through to the infrastructure. So we really need kind of a 360 view on things. It'd be really good to be able to monitor stuff from a server perspective and then from a customer perspective. So, you know, accessing an application as if you were a customer sitting at a computer or actually from the server itself. Again, infrastructure, we need to look at runtime and proactive monitoring of what's going on under the application environment. And then to be able to do some sort of correlation between when an application has an issue and then correlate that to events that happen within your infrastructure as well. So we need to kind of be able to look at things end to end, and then whenever there's an application problem, to be able to correlate that to whatever's happening on the infrastructure at the time. But really, in other words, this kind of means when developers are complaining and pointing the finger at infrastructure, that you guys have got all the tools that you need to be able to tell them to go jump or whatever you want to do. So let's have a quick look at SCOM 2012. So like I mentioned, Ops Manager now really gives you kind of a good 360 view on your whole environment. You can monitor the infrastructure layer, the application layer, and everything from a user experience point of view. And what this kind of means is to be able to do synthetic transactions, basically to simulate an application, hitting the web servers, for example. Then we've got the .NET monitoring using the APM agents as well. There's some really good dashboarding now in SCOM 2012. So there's a really good framework that you can use to extend the default views and stuff you get out of SCOM, which allow you to build really good dashboards. And of course the management packs. So the management packs are really key to getting all the advanced performance alerting and reporting out of your infrastructure that you need. And then the last component really, I guess, is the cloud monitoring. So to be able to look at any of your workloads that are running in the cloud and to be able to bring them into a single pane of glass so that you can view the alerts, do performance monitoring, and then reporting as well. So in R2, the main improvements really, there's not a lot, to be honest with you, but from what I've seen, the Java APM really is the main thing. So in 2012 SP1, we do the .NET monitoring using the APM, but now they're bringing in Java. So we can monitor .NET and Java applications as well in exactly the same manner. Improved dashboarding and improved integration with VMM, and like I said, the Azure Management Pack is going to actually get improved because it's still in preview. So let's have a quick look at APM. So as I mentioned, it's fully integrated into SCOM 2012, and it's .NET monitoring, part of the Avicode acquisition, and allows you to monitor .NET hosted applications and Windows services. Yep, sure.
You comment there, you're saying you're playing without source code modification. I'm under the impression that you really have to instrument where you really get the full benefit out of it to actually get the benefit out of APK.
So the question there is around the source code modification. So you can apply the APM agent without modifying any source code at all. There are scripts and Java components that can run outside of your source code. So yeah, there is a way to monitor it and without modifying any source code at all. And you do get some really good information back. Yep.
Are there benefits to modifying? I mean, what can or would you do to modify the source code if you want to get the most out of it?
Yeah, there's some stuff in the SDK, basically, which allows you to add extra logging and I guess functions within the source code, which then means it populates even more stuff. So yeah, there is something that you can do to modify the source code, but you don't have to. The stuff I'm going to show you today is all about not modifying the source code, and it works really well. So it gives you a really good comprehensive view of your application health state and allows you to do some workflows for problem management as well. It's end user browser driven monitoring, so it's essentially looking at the application from an end user point of view. And it's got some built-in analytics and reporting as well. So how it works really is essentially you have the web application running on an IIS server, and then you've got the APM agent installed on the same box. So this is when you install the SCOM agent. So by default, the APM agent is actually disabled. It's a Windows service. So you need to go in and enable it and set it to automatic. You then deploy your .NET app onto the server. The APM agent then starts monitoring the application based on all the stuff that you configure in SCOM. And then it monitors for any exceptions or performance errors that come up that you've specified. And then sends that from the APM agent into the SCOM management server. So we'll just jump over now and have a quick look at APM. Any questions before I jump to the demo? No? Cool. Okay, so I'm demoing here our live SCOM environment. So I'm not going to make any modifications to anything, but you can see, you know, exactly how it's working in a real environment. So basically, like I mentioned, the APM agent is installed by default but disabled. So as soon as you enable it, then you can start configuring the stuff in the management console. So here we need to configure the .NET application performance monitoring. So we would go through the wizard. And give the monitoring a description. Select your management pack where you want overrides to go. So we have one that we send all the client monitoring to, for example. And then we need to specify what we need to monitor. So this basically has an inventory list of all the .NET applications that exist in the environment. So if you do a search, you can obviously do a filter, but if you do a search, then you'll get to see all the .NET apps that SCOM has picked up based on all the agents that are out there. So I'll just pick one, for example. We add that in, go OK. So you can also specify what kind of environment it is, whether it's a production, staging, test, development, or something else that you want to call it. So this is really a way that you can add tags to the monitoring as well. So you might have a test environment and a production environment and kind of separate the monitoring out. With the wizard only gives you the option to configure the server-side configuration, but after you've completed that, then you can go in and configure the client-side stuff. So by default, it sets the threshold to 15 seconds for performance, which I think is quite high for a web page, for example. So in our environment, we've got everything set to 5 seconds, for example. And then in the advanced settings section, you can configure your thresholds and sensitivity and performance events per second. So all your thresholding can be done here. We go next. So here it gives a summary of what's going to be configured. The important thing to note here is IIS will need a restart. So obviously I'm not going to do this now in our production environment, but you do need to make sure you take that into account when you are configuring the monitoring. So let's have a look at one that I've pre-configured so you can see the client-side monitoring that can be done. So this one here, for example, so the server side is exactly what we've just seen. The client-side monitoring, very similar. All your thresholding and sensitivity and those sorts of settings as well. Any data collection items that you want to select as well can be configured here. Any load balancing settings, any pages you want to exclude from monitoring. So you might have an example is with this particular application that we're hosting, there's one particular page which is used for uploading files. So that will breach the 5-second threshold because it could be uploading for 10 or 20 seconds or 30 seconds depending on how big the file is. So you can exclude that from monitoring, for example, and then you won't get alerted to the performance of that breaching. Any questions so far? Yep, sure.
Just wondering, back a couple of steps when we were looking at the server-side monitoring the IIS website.
Yep.
Are you able to now browse through the actual methods available, or do you still have to find the DLL and branching out?
I believe you still have to find the DLL. Yep. Demo fail. Jesus. No. Right. So under monitoring, what we get now is application monitoring and .NET monitoring. So here you can see all the different applications that I've got set up that we do monitoring on at the moment. If you want to look at things from an overview perspective, then you can look under monitored applications. And I'll just, so here it lists you know, whether they're in a healthy state or a warning state. And then you can, from here, you can go and have a look at the Health Explorer and it will tell you exactly what the problem is. So this one here, I think, needs an IIS reset. Yeah, empty scope target. Cool. So if we have a look at the Easy Visa one, which is the one I was on before, I'll show you some alerts that we're getting for this site, for example. So overall component health gives you an overview of what's going on with that application, and then you can see all the active alerts. So if we have a look at this one, for example, the questionnaires page is breaching the 5-second threshold. So from here as well, we can click on the link and go to the advanced diagnostics, which will give us more information about what's going on with that alert, for example. I'll just zoom in and see if that's a bit easier for you guys to read. Is that a bit easier? Gee, Zoom, it's not playing very well. So from here, you can see that the questionnaires page is taking 7 seconds to load. If this page was calling other pages as well, we would see the flow-on effect if it was calling other services, and I've got another one that I'll show you around that, for example. So this page here does make a SQL call. So we can see here that the SQL query actually is really not part of the problem at all. It's something internal to the actual application page itself. So then we can take this information back to the developers that develop the app and get them to do some more analysis on their application. The tabs across the top, so we can see some similar events that have been happening. So this has been breaching for a little while, and any related events as well that occurs. Gives you some information around distributed chains. But I think the most important one is the performance counters. So this is basically grabbing some perfmon stats off the server when the alert happens. So this allows you to basically have a look at a quick snapshot of the server to see what's been going on at the exact time of when the alert was triggered. So from here, for example, we can see that the processor percent time was really doing not a hell of a lot at the time. This server, for example, has got 2 processors in it. So I know that, for example, we need to go down to the bottom and add that in so we can look at what's going on with both of them. So we can see there that one processor was kind of doing 48% and the other one was really doing not a hell of a lot. And if you look through the other performance stats, you can see information about disk and memory and network. So you can kind of have a quick look and see what else was going on with the box at the same time. But you can kind of tell that there really wasn't a hell of a lot going on with the server at the same time. So again, take the information, send it back to the developers and get them to do some more analysis to see what's going on with that page. I'll show you another one which actually calls another web service which gives us more information. So this one here, we run an application from Citrix. It's called the Cloud Portal, which allows us to orchestrate all our provisioning and stuff. So one of the pages here is breached the threshold again as well. This one we've only got set up to 15 seconds as the default, but you can see it's still breaching that threshold. So that's kind of, that's pretty concerning as to why that was happening. So if you have a look, you can see the URL that was triggered to access the application. You can see the host address. So everything of ours is behind a load balancer, so we only see the load balanced address, for example. And then here you can see the different transactions that have happened, that have been triggered from the page. So you can kind of see here that it's making calls to other services. So this is an AD group search service, for example. And then here it's actually called a remote service on another server. So it's actually called a web service and that kind of method. So we can very easily see exactly what's been going on and where in the whole process of that web call where the actual problem is. Any questions at all on that before I close it?
Just in terms of overhead,
So the additional stuff that it gathers essentially is all the tracing that you've kind of seen. And so yeah, there's a small overhead. There's going to be a small overhead with anything like that, right? The performance monitoring stuff is being gathered anyway because there's a SCOM agent on the server. So really, it's kind of a really minimal amount of tracing that it's doing within the application itself. Any other questions at all? Yep.
How does that scale in terms of the number of applications that you can be monitoring like this from, say, a single monitoring service?
Yeah, so there's definitely a limit. I think at the moment, from memory, the limit is about 400 .NET applications that can be monitored using the APM. Obviously, with R2, they're kind of scaling that so that you can monitor more. So yeah, it does create a performance overhead on the operations manager server, which is why they've kind of limited it to 400 at the moment. I'm pretty sure it's 400. Any other questions at all? Yep.
Can you use that on applications rather than IIS servers or web pages?
It's only you can only use it on .NET applications within IIS. Yeah. So if you've got an application that doesn't use .NET, for example,
Runs as a service or something.
yeah, or even just a flat HTML page or whatever, it's not going to pick it up at all. Yep. So it's only .NET. The performance data that you can have a look at basically allows you to look at the number of requests and number of events per second and the performance and the average time as well. So if we kind of pick a couple here so we can see the average response time of that application, then obviously with SCOM you can pick your time range as well. So then we can look at that over a 7-day period, for example. So you can do this on every single application that you're monitoring. And then obviously we can go off to different reports as well. So it'll pull stuff out of the data warehouse via SQL reporting services and it allows you to generate reports as well that you can then export to PDF and send off to other people as well. Yep, question?
Just with those spikes, if you see a regular spike at a, say, 11 p.m. every day, is there flexibility in the tool to look out for those?
So the question was if there's a spike at like 11 p.m. during the day or 11 p.m. during the night, is there a way to look and see what else is going on at the same time? And
Or even just ignore them. Say, for example, you know that there's a backup happening at that
Yep.
time every day. Is there facility within the 8 p.m. monitor to I suppose, exclude them?
no, there's not. So you can't do any kind of exclusions during a time window. So SCOM doesn't really allow you to do that anyway. You've got to kind of do that with your scheduled maintenance. And the only way to really do that really well with SCOM is to use Orchestrator. So you would use Orchestrator to trigger a scheduled maintenance on a particular object, and that will take it out of service for that period of time, and then you can bring it back in service as well. Probably one of the other things worth mentioning just on that is one thing that it doesn't allow you to do is correlate events. So if there's an event that's triggered like at 8 o'clock at night or 11 o'clock at night, which is for a backup, there's no way in the SCOM console that you can kind of get a really good view on all of the events that have happened at that same time. So you would need to do some searching and reporting to actually gather that information out. Any other questions at all on APM? No? All right. Okay, so the Windows Azure Management Pack. As I mentioned, it's kind of in preview at the moment, and there's definitely some quirky things with the management pack, and there's some stuff that's actually broken. But essentially, it kind of gives you a really good overview on the services that you have running in Azure. So it'll look at your cloud service, any applications that you've put up into Windows Azure, any virtual machines, your storage that you've got up there as well. It'll also check certificate health. So if you've got any certificates loaded into the Azure console, it'll check those as well. It's got a new notion of a kind of distributed application template, which kind of means that you can pull together in a monitor an application that you might have where some of the web tier sits in Windows Azure and maybe some of the database tier sits on-premise. And it's got a monitoring dashboard as well, which kind of gives you a really good overview of all the different topologies and resources and capacity and stuff that's going on as well. It does have performance metrics in it as well, but that is one component that's actually broken in the management pack at the moment. So I've kind of listed out here in the slide deck all the different things you can monitor. I'm not going to go through all of those now, but suffice to say, when it is RTM'd and everything is working properly, then all this sort of stuff will be fed back through into the SCOM console. So just before I jump into the demo, so in order to get the Windows Azure Management Pack actually working, there's a few things that you need to actually go through. I've included some links in the back of the slide deck, so when you download the slide deck, you'll get all the information that I've put in there. But essentially, so before I go into it, who's used Windows Azure before? So who's got stuff in Azure and on-prem where this would be really handy for? Yep, a few of you. Yep. So, you need to take your subscription ID, which is obviously tied with different subscriptions you have in Azure. You also need a certificate. So the certificate has to be uploaded into Azure, into your management console, which I can show you. And then you need to actually import that into SCOM as well. So it kind of links the two, and then it uses that from an authentication point of view when it authenticates to the service. Okay. So basically the management pack is kind of similar like all of them. It's just a download, install, next, and away you go. So basically here under the administration part of SCOM, you get a new option for Windows Azure. And here you just need to add your subscription. So obviously you can add multiple subscriptions if you have different subscriptions for different customers or different environments. And literally you put in your subscription ID, the certificate that you've generated. So you can either generate a self-signed certificate using utility, something like MakeCert, for example, and then the password. The proxy agent, which is obviously the next step in the wizard, which I won't go through, is essentially the server that's going to be doing the watching of the service on your behalf, on SCOM's behalf. So in the current version of the management pack, you have to select the SCOM management server that does this. So normally what you would have is like a watcher node, for example, which is just like it's just a SCOM agent, which you then select as the node which will actually do the monitoring on SCOM management server's behalf. So at the moment, in the current version of the management pack, it has to be done on the SCOM server. And then that SCOM server does need internet access, so it can go out and make the web service calls. So the only good thing that I've found with that is the fact that you can specify a proxy server. So the SCOM management server doesn't have to have direct internet access. It can go through a proxy, which is how we've got it working, because we don't allow direct internet access out from our environment, for example. So once you've configured the details there, then you need to go into the authoring section to start adding in some of the services that you want to monitor. So let's just give it a name. So you pick your subscription. So what you kind of need to do here, oh, that's nice. Thanks, Seth. What you need to do here is pick the cloud services that you want to monitor. So it's not going to go and automatically find them all and monitor them. It will go and find them all, but then you need to specify which ones you want to monitor. So, for example, I won't continue with that wizard because I've already got one set up. But for example, I'll show you some that I've already configured. So at the moment, I've only got one cloud service selected, one virtual machine that I'm monitoring, and some storage accounts. But if we flip over to my Azure console, so I've actually got 2 cloud services, but I'm only monitoring one of them, and I've got 2 virtual machines, and I'm only monitoring one of them as well. So it doesn't automatically pick up and add all the servers that you want to monitor. You need to go in and make sure you actually include them. It will, however, pick them up from an inventory point of view. So I'll just flip over to the monitoring section, which will show you that. So if we go down to Windows Azure. So the topology dashboard will give you an overview of the different topologies you've got. So if you've got, for my demo, I haven't actually got a massive topology in Azure, but if you've got lots of things set up with lots of dependencies, then the topology diagram it's clickable, so you can click through and it will bring all the items up. Under the Azure resource inventory, so this is where it's discovered cloud services. So you can see here, I'm only monitoring one of them, but it's picked up the other one, but it's saying that it's not monitored. So we need to actually go in and select it so that SCOM does start monitoring that. The same with virtual machines. So there's some information, obviously, that will pull through from Azure. So the instance type and the display name. There are some extra things you can configure in the view. Not on that one. Where is it? Cloud service. Yeah, so under cloud service, there's a lot of additional things that you can add into the view. So one thing that you need to remember with SCOM is the default view that it gives you for kind of every, I guess, anything in SCOM that you're monitoring, it doesn't always select all the things that you can view in the SCOM console. So if you haven't already, make sure you go in and have a look at the personalized view section, because there's generally a heap of stuff that you aren't seeing that you possibly could be. So here you can see there's lots of information that we can pull out, you know, that will add it to the view in SCOM. So if we take a look at the actual monitored resources, again, the view is probably worth taking a look. So there's extra stuff that we can add in there. To be fair, I don't actually think that this is pulling out as much information as it could be. So like I said, it is in preview. So hopefully in the next version, it is actually going to pull a lot more information out. Under the performance section, like I mentioned, the performance stuff is actually broken. So there's no actual performance data that you can pull out. But it would be very similar to any of your SCOM agents that you're seeing from a performance point of view. So you'd be able to pull out, you know, CPU, memory, network and disk. Probably all the similar stuff that you'll see in the Amazon management pack that I'll show you shortly. So any questions on the Azure management pack at all before I move on? Yep.
Yeah, so is this just pulling stats straight from the Azure service? It's not requiring an API there?
Yep, no, it's basically using the API. So it's connecting to the API and pulling the information out. So it's probably one thing to take into account is it's not real time. So there is a lag. So discovery, I think from memory, it only runs every 30 minutes. So if you kind of do stuff in Azure, then it won't actually find it in the SCOM console for maybe about 30 minutes until you can pick it up and then tell it to monitor it. Same with all the performance metrics and stuff like that. The Amazon one's going to be exactly the same. It's not going to do it in real time. It's going to do it on a scheduled basis. I think the Amazon one is about 5 minutes. And probably I would guess the Azure one would be something like that as well. So that's kind of one thing to take into account. Yep. Yep. Yeah, you. Sorry.
If you've got a site-to-site VPN set up with Azure,
Yep.
will that monitoring happen over that VPN tunnel, or does it happen via the internet still?
No, it makes a direct call out to the API. So I don't know exactly the URL that it calls out. I haven't managed to find that out yet. But my guess would be it's a separate actual API for monitoring. No, so the only thing you can monitor is like what's in the console there. It's virtual machines, storage, your cloud service, and certificates and stuff. That's kind of about it. I haven't seen any information about what's coming out in the R2 drop to see whether they're actually adding in extra stuff. I'd be very surprised if they don't, because there is a lot more stuff in Azure that's not in the management pack, for example. Yep. Yep.
When you pick the proxy or the watcher node, are you limited to one, or can you have multiple, so you don't have a single point of failure?
So the question is around watcher nodes, whether you can select, whether you have to select one or whether you can select multiples. So with the Azure management pack, at the moment you can only select one, but the way I understand that it's going to work is it will allow you to pick multiple watcher nodes. So at the moment, like I mentioned, it's only on the SCOM management server that's doing the monitoring, and in the final release that's going to come, they're going to allow you to do watcher nodes, and I have heard that they're going to allow multiple. So yeah, then it will be kind of redundant, a bit of availability there. Yep. There was another question.
No, that's all. That's good.
Yep. Okay. Cool. Okay, let's get on to the Amazon management pack. So who's got stuff up in Amazon at the moment? It's about half the room. Yep. So the Amazon management pack allows you to look at your EC2 instances, the block storage that sits underneath it, any load balancers that you might have in Amazon, any cloud formation stacks that you have set up as well, and any auto scaling. So it basically discovers all those components, and it uses CloudWatch to basically pull in all the metrics regarding those services. They're all kind of bubbled through into SCOM using, from a performance counter perspective, but also it brings in any alerts. So I don't know if you've seen when you get alerts to say that your instance, for example, is going to be restarted on a certain day and time because they're doing maintenance or whatever. That will actually bubble through into SCOM as a SCOM alert. It discovers any instances that you have set up that you have SCOM agents installed on as well. So you might have SCOM agents actually in Amazon on your EC2 instances and pointing back into your SCOM management server, for example. So it kind of picks that up from a deep linking point of view, and actually gives you a bit more information regarding that. And it's also SCOM 2007 and 2012 compliant. So the management pack, there's two versions of the management pack. You just install whichever one you need for the different versions. Just a quick look at the architecture. So like I mentioned, with the Azure management pack moving to more of a watcher node perspective, the Amazon one is already there. So this one you definitely can select multiple watcher nodes already at the moment. So essentially the watcher node is a SCOM agent, a server that's got a SCOM agent on it, and it needs internet connectivity. So this one you cannot use a proxy server to go through, so it needs direct access out. It needs the Amazon Windows SDK installed on it as well, and .NET Framework. And basically the monitoring is done from that watcher node, so it makes API calls up directly to the Amazon services, the console, and also the CloudWatch API. And as I mentioned, if you've got any workloads actually in Amazon with SCOM agents on there, then those SCOM agents will come back through and talk to your SCOM management server. Obviously, if you've got stuff running in the cloud and you want it to connect back through, then I would recommend putting in a SCOM gateway server. So this watcher node does not work on a SCOM gateway server. We tried to do that, and part of the components that it needs, it's not actually there. So don't try and install it on a gateway server. But obviously, I would be using a gateway server to connect back into your environment.
So,
Sorry, it was.
watcher node, you're saying run a gateway server to monitor directly into Amazon and come back to SCOM and not necessarily worry about the watcher node so much?
So the gateway server you would deploy if you were having SCOM agents on your EC2 instances. So they would connect back through the gateway server before they come to your management server. So don't have kind of a direct connection back in. And then your watcher node is used for the Amazon API monitoring. Any other questions? So there's some state views as well, which we have in the SCOM console. So it's got some really good information in there, which I'll show you about the frequently used information that you would generally see in your AWS console. It gives you really good information about the zones and the resources that are assigned to your VMs. It'll also tell you what kind of VM it is, whether it's a Windows VM or something else. There's also some really basic troubleshooting as well built into the console. So you can start and stop and reboot EC2 instances from the SCOM console, as long as the user that you've set up has access to be able to do that in your AWS console. So you need to make sure that if you are setting this monitoring up, then obviously in the AWS console, you need to make sure you have a user account that's got access to access the CloudWatch API. And then if you want it to be able to restart EC2 instances, then you need to make sure you give it additional credentials, additional permissions. All that is kind of documented in the Amazon online documentation, which I'll show you. I've put a link to that as well in the back of the slide deck. And it kind of steps through exactly what you need from a permission point of view. Then there's a diagram view as well, so it gives you a good view from the stack all the way through to the instance, and the instance all the way through to the resources as well. So there's plenty of good linking there. I think they've done a really good job with this management pack. It's definitely heaps better than the Azure one, for example. These are all the CloudWatch metrics that it pulls out. So it's pretty comprehensive. I won't go through each of them there, but that's there for you guys to reference if you need to. And then we'll have a look at it now. Any questions before I move on to the demo? Yep.
Can you pull out custom metrics as well?
Can you pull out custom metrics was the question?
Amazon, you can define custom metrics coming directly out of the EC2 instances, so you can actually get OS level information as well.
Yep.
Maybe fed out through the same system.
No, so the metrics I showed you before are kind of the only ones that the management pack pulls out. So the only way would be to create your own management pack, for example, which depends whether you want to go through that. Yeah, it's a bit painful to do that. Any other questions, sorry? No? Okay. So as I mentioned, you need to install the watcher node and configure all the prerequisites and stuff that you need before going through the authoring wizard. So here basically, after you've installed the management pack, you'll get a new Amazon Web Services section. And it's just a matter of bouncing through the wizard and selecting some settings. I'll just do this. So basically you select the watcher node, so you can select multiple watcher nodes if you want as well. And then you need to select your AWS Run As account. So this is basically an account in SCOM that you set up. It's just set up with basic authentication. So if we have a look at the accounts. And then under credentials, you just set up your security credentials that you get from your AWS console, and then away it goes. The one thing that I would recommend doing is making sure you select the distribution option and make sure you're only distributing those credentials to your watcher node that's being used. So by default, it's set up as less secure, which basically means it'll distribute those credentials to every single SCOM agent. So I'd recommend you make sure you change that. And then once we've done that, discovery process will run, and it will take a little bit of time to discover all the information. with the AWS management pack compared to the Azure one, you don't need to go in and select things that you want to monitor. The AWS one will automatically find everything from a discovery point of view and it will automatically add it to the console. So as long as that user account has got access to view all the CloudWatch metrics that you want, then obviously it'll pull all that information out. The way to potentially have it separated would be having different accounts set up in AWS with different access to different parts of the console, for example. So we get a pretty good overview of the watcher node health, for example. If you've got multiple select there, you'll see them. Any AWS alerts that will come through. So like I mentioned, the one we saw was around the rebooting of the instance that had to happen, within the maintenance window, for example. I'll come back to the performance. So the load balancers, I've created a test one, for example, just to show you all the information you can pull out. So the detailed view down the bottom here will give you pretty much all the information that you'll be able to gather from the view settings across the top. So like I mentioned, by default, it's not selecting and giving you all the information. So make sure you go in and pick the bits that you want to see. So there's plenty of information there that you can pull out. Same with the EC2 instances. So here you can see all the different instances and the health of them. One thing I've noticed though is that the instances, if they're turned off, still report as healthy, for example. So one of these instances I've got set up is actually turned off, but it's still reporting as healthy. I'm not sure whether that's a bug or whether it's actually supposed to do that, but that's what we've noticed. So here you can kind of see there's plenty of information around your instance type, the public IP address, when it was launched, any tags that you've got set up, whether the EBS volumes are all optimized or not. And as I mentioned, have a look at the personalized view. There's plenty of stuff that you can check and uncheck as well. So I've only selected part of it, but there's heaps of stuff in here. Regarding performance, so these are all the performance metrics that you can pull out. So we've got volume read operations, queue length, read time, read bytes, write bytes. Let's pick this one here. Network in and out, CPU. So there's quite a bit of information there that you can pull out and pull into the dashboard. The one thing I don't like is the fact that this dashboard has got basically everything in it. So every single server that you've got in Amazon plus every single metric. So finding stuff that you want to put into the dashboard is pretty difficult, but if you use the searching feature, for example, you can just type in some keywords and it will pull out all the metrics. So here we can view some CPU information regarding the instances, for example. And hidden over on the right here is the start and stop and reboot instance. So one of them, for example, I've got turned off at the moment. I'll just double check which one it is and then we'll start it up. Okay, so that one there. So let's start that instance. So Easy Visa. And that will trigger the API call to start that instance. Here we go, it's starting up now. So a couple of things to be aware of, especially with that starting and stopping of instances. If the AWS account that you're using that you've configured in the monitoring section doesn't have rights to be able to do that, then you'll get errors in the SCOM console. Same with if you trying to start an instance that's already started, then you'll get some errors as well. So just be aware. And then you can see that instance is running now. So one thing that I don't like about this management pack as well is the fact that it's very difficult for you to find out which instances are running and which ones aren't. So the only way that I could kind of tell that, for example, was to look at the instance information and then go through and find out which one had a private DNS set up. So that means obviously the instance is started and it's got an IP address and it's been set up in the DNS within Amazon. So that is pretty much the only way that I've been able to find out how I can tell which ones are started and which ones are stopped, for example. Any questions at all? Yep.
Can you control your access to SCOM so that you can have that start and stop feature there, but also give people access just to view only as well? Like what sort of granularity?
So I don't know if you can do that for sure, but I would think that you should be able to do it based on creating a custom view based on the management pack, for example. So I would imagine that you would have to customize this EC2 instances view or create a new one, for example, and then you would just hide some of the stuff that you don't want them to be able to see, for example. But I don't know for sure. Yes, mate?
Knowing that you're tricked there with the private IP then,
Yep.
could you set some sort of alerting mechanism on that so if the server drops out, it doesn't have like the private IP address, just so we can identify when it's a stop running?
So the question was around whether you can specify, set up a alert to trigger it, for example. So not that I'm aware of, because literally as you see, the VM was turned off, and there's no alerting at all that happened that the VM was turned off at all. There's no alerting that has specified that it's been turned on. The only way that you'll get that kind of enlightenment is if you have a SCOM agent inside the EC2 instance. And so if you do that and then have it connect back through, then you'll definitely get that enlightenment, for example. And so then you'll know whether the VM's on or not, because you've got an agent on it. But obviously that's going to cost you some money as well to put the agent on there. Yep. Any other questions at all? Okay. I'll move on. So the Global Service Monitor. So this is, like I mentioned, it's the service from Microsoft that allows you to do outside-in monitoring. It allows you to check your application availability and general performance as well. So you can basically set up this to monitor response time and different metrics within response time as well. So you can kind of see if the DNS is taking a long time to respond, or whether the page load is taking a long time to respond, or the actual request for the URL is taking a long time. So you can kind of see quite a bit of information in there. It also allows you to do monitoring not only from the Global Service Monitor, but also from other SCOM agents or other nodes within your network. So you can kind of, the way that I would probably pitch this is if you've got a distributed environment where you've got multiple sites, for example, then you can have SCOM agents on servers in multiple sites internal to your network and have this monitoring set up so it monitors outside in, essentially, out from the data center into your SCOM environment. The GSM is worldwide, so Microsoft have put this service in multiple locations. I think it's 17 locations across the globe, including Sydney, and it's a free service for customers that have got software assurance. So essentially, in order to get it, all you need to do is have a valid software assurance account, and then you need to go through and register on the website. So they're all the locations that you can have set up to do the monitoring from. You can select all of them if you want, or you can just select one. And that's a quick overview dashboard as well that you can use to have a look at, see what's going on with your application as well. So I'll just jump into the demo. Any questions before I jump into the demo regarding GSM? So from what I hear, it's running on Azure. But there's a node in Sydney, for example, so I don't know what's actually going on there. But from, hey? Even though the node is in Sydney? Right. So, so that's one thing to take into account. Okay, so the way you configure this, after you install the management pack, you then get a new option here, the Global Service Monitor. Obviously, I've already set up the subscription, but if I do the update proxy server and certificate wizard, you'll get a view of what you'll see. So this is the kind of same thing that you'll see when you go through the wizard for the first time. So here you need to sign in with the account that you've used to kind of register. So in the back of the slide deck again, I've put some links in there, so how you get to register for the service. So essentially you register it on the Microsoft site, you link it to your subscription, and then you come in here and sign in with the same account, and then it basically picks all your information up.
Question, sorry. Okay.
Yep, sorry.
Does this then flick back to Azure, or this is just the actual setting up of the management pack, so you can do localized agent synthetic monitoring?
This is just for the Global Service Monitor. Yep.
Yeah, I mean the global service, but is it still registering back with Azure? Or
No, it's completely separate
this
to.
is just internal?
It's completely separate to the Azure subscription. Yep. Okay, so once we've got that set up, then we need to configure some monitoring that we want to set up. So here you would do it under the Web Application Availability Monitoring. So go through the wizard. Select your management pack for overrides. Okay, so here we need to specify what we're actually going to monitor. So in here, for example, I'll put in another customer's website that we host for. So and then the URL. Yep. So here you can specify multiple URLs, multiple pages as well. So if you want to only monitor certain pages within the URL, then you can do that as well. Obviously, if I'm just selecting the URL, it's just going to load whatever the default page is, for example. You can do HTTPS as well if it's a HTTPS site. So where you want to monitor from, so like I mentioned, you can do internal locations or external. So this one here, I'm just going to select an external location. If you do a search, it'll give you all the locations that's available to you. So this one here, let's do Sydney, London, Miami. Then obviously we can select internal ones as well. We can change the configuration here as well. So the test frequency, when it gathers performance data as well, what kind of timeout settings you want to set. So like default as 45 seconds is quite high for it to time out, for example. So you might set an alert that it generates an alert after 15 seconds, for example. Here you can monitor transaction response time and stuff as well. The HTTP error codes that you get back. So we can generate single alerts or multiple alerts depending on how you want it to be configured. So this is like kind of roll-up alerting. So it'll either do a roll-up alert or alert on every single test and every single URL. This is the performance data that will pull out by default, and obviously you can select response time and download time and TCP connect time as well. any HTTP headers that you want to send with the request as well, so you can add these in here. So you might specify some custom headers that you send through in order to pick it up in some other weblog monitoring that you might be doing. So then you can kind of pull out these monitoring transactions from any kind of reporting that you might do. And then specify the proxy server if it needs to go through a proxy server as well. So let's have a look and see what that looks like. So under the web application availability monitoring, so we'll get an overview status on all the sites. On the right here you can see there's a couple of dashboard views as well. The summary dashboard is the map view that I showed you before. I won't show you that one because it takes quite a while to load all the different locations, for example. But here you can see all the different locations that we are testing this from, and then we can specify which transactions or tests that we want to look at. So if we have a look at the Sydney one on this one, for example, then we can kind of see all the metrics that we've specified that we want to monitor, and then we can specify multiple locations. So then we can have a look at all of them. So you can kind of look at all the different locations regarding a single test, for example, on the same dashboard. And then obviously it'll give you all the individual test scenarios as well, so all the different URLs, the different locations that you're testing from. This will give you the test state view, so each of the individual tests, and the application state status is obviously an overview status as well. That's pretty much it from a GSM point of view. Are there any questions at all? No? Okay, that's pretty much all I had for today. So hopefully you guys have got a good overview on the kind of 360-degree type monitoring you can do in your environment, and all the different tools and management packs that you can use to do that. Like I said, at the back of the slide deck, if you download it, there's heaps of links that I've put in there, which will help you get all this up and running in your own environment. Yep.
One question, compatibility of GSM, via
2012, yeah, GSM requires 2012 SP1. Yeah, so this is on SP1. Yeah, it needs SP1. Yep. Yep.
Sorry, not native 2012 SP1 or?
Correct. Yep. Requires SP1. Yep. Any other questions at all? Cool. All right. Thanks, guys. That's it. Thank you. Hey.
Does Go give you the ability to do end-to-end testing? I.e., well, I've got a service desktop
Yep.
and I want to emulate login